I told Susan, my wife, the other day, I said, you know, it's amazing how you can be like, oh, I don't need to take a shower today. I'm not going, I don't have to go to work anyway. I'm just working online. Well, welcome everybody to our IoT class for today. It's the 26th of March. Thank you for being here. I know we've been unable to really meet a lot because of different things going on with me and with things around and about, but I do want to spend a couple minutes today just talking about some things and trying to see where everybody's at and how you're doing. The first thing I want to do is there is a launch going on, so I may jump over here and we'll show the launch if this thing ever starts. But there's a ULA launch today of a big site. Always cool stuff. But one thing I want to tell you is I know in our class, the two parts we're working on is IoT fundamentals and IoT connecting things. After doing more research and looking at this, one of the things I have really noticed is the amount of overlap between IoT fundamentals and IoT connecting things. You've probably seen that too. It's not necessarily a bad thing, and I'm sorry if my internet's unstable. If it's not usable, then I'll have to change something. But if I break up a lot, Kendra, let me know.
Okay, you have a little bit.
Yeah, let me do this. I'll turn this off. That way I'm not streaming that over there. I hate to. This is the sad thing is my phone. I'll take it off my Wi-Fi and we'll put it on my phone and then it will just be sitting there. So there's a lot of overlap. Many things are repeated. It's not exactly repeated, but they are repeated enough that it may be something that you would see a problem with if you use both of them in a class. I had never had a problem with repeating things for my students because it seems like they need it 2 or 3 times. I muted myself to sneeze so none of you would have a heart attack when I sneezed, even though we're face to face. You will notice that as we look through here, most of the things in chapter 1, when we look at them, have been covered in the fundamentals, looking at sensors, actuators, controllers, the difference between open and closed loop control systems, which really are kind of interesting. Because you think about an open loop system, you would think that would use a feedback loop, but it does not. An open loop does not have a feedback. It basically just says you put in the right amounts and you put in an input, the controller then will create an output. So like a dishwasher, you run for a certain amount of time, soap and water, you put your inputs in, and then the plant or the actual device runs that system, and then the output hopefully is clean dishes. That's different than a closed loop system, which again doesn't make a lot of sense to me why they went with this, and maybe one of you can explain it to me better, or someone I'll have to do more research on it. But in a closed loop system, you're getting feedback, and this would be like your Nest controller in your house or your HVAC controller, because you put in a certain temperature on the controller. The air conditioning or HVAC attempts to get to that temperature. You're monitoring what that would be through a sensor, and then that will change what happens to the controller. So once you hit a certain temperature, the controller will force the plant to change to a different thing. One of the things I'd use here as an example would be the Nest thermostat, and it's called eco settings, where you can say if the house is colder than 60, turn on the heat. If it's hotter than 78 or 80, turn on the air conditioning. So you've got a sensor there looking all the time, trying to say where it fits in those ranges, in the sensor range. So the sensor's continuously giving feedback. And again, to me, it just doesn't make a lot of sense that a closed loop system is one that you've got technically out external feedback coming in. But again, I'm sure there's some reason. It's just like when we look at the fact that, you know, the way when we look at electrical circuits use the incorrect way for the way electrons flow. So by the way, if you don't know that, basically electrons flow negative to positive, but almost all circuits show it positive and negative. And the reason is that's how it was originally written. And once they found out it went the other way, they just said, well, all these textbooks and everything and all of our examples are this way. It really doesn't matter. So we'll just make it like this. So, but I thought that was interesting in a closed loop system. But as you move down through here, obviously these are things we already know, OSI and those. Now, into chapter 2. Now, one of the things I have not done, folks, there are packet tracers here. I've got to build the uploads for these, so that's coming. So you'll have an upload for each one of these. So when you get done with them, you can just upload them. Likewise for the labs, I'll build uploads for all of these. It will once again not be a link to them. It will be like our previous class, which is where where you go in and there won't be any under the modules. There will not be a an item for each one of them. So in other words, like I said, I did the packet tracers here, but when I put them in, I didn't necessarily drag them all over. In fact, if you look over here at the assignments, instead of trying to add them to every single one, I've just got them all sitting here in the assignments so that we don't have to do that. Now, I eventually will build it out because everybody will want that for their classes, but you'll notice I didn't put my neat little packet tracer, and there's not a link. When you go here, there's not a link to go to this lab. There's just an upload for it. So this is just so you can upload that particular assignment. So I'm not going to do links. Part of the reason I'm not doing links is if they convert these to the new curriculum or new curriculum type, which I figure they will eventually, you won't have those links. So you won't have the you won't be able to make the links as easily as we used to. So just be aware of that when I do that for connecting things. But we're looking here. If you take a peek, let's go back over here. Introduction IoT. Let me pull it up real quick. Chapter 1. Sorry, I keep going back and forth. There we go. Chapter 1. So if we look at our index, you'll see again some things that are related in the two. So, but one of the big things in connecting things as we move on down, there is another section on Python scripts and getting more into actually using the that PL app and using the Cana kit. And the Cana kit is the kit that is recommended by Cisco for use with this particular course and actually with the fundamentals course. It is different from the kit that I showed you from Freenove, but many of these labs, that's what they work. Actually, all these labs, that's what they work on. They work on using that particular kit. If you ever are interested in what is needed for these classes, don't forget you can always go to my NetAcad resources, course resources, and then go to the course itself. So IoT connecting things, English, and it will tell you under scope and sequence. It talks about different lab files and everything else. So if you're ever looking for the student lab source files, if you're ever looking for the instructor files, those are all there. Any questions about that?
Not yet.
Okay. How many of you have actually started working on the connecting things?
I have not.
Okay. One of the things I want to do, and I want to get your opinion on this before I move forward. Looking at Intro to IoT, and we've got three of you here. Who else is here? Oh, it's just us three. So Todd, so y'all can give me your opinion here. With the IoT introduction and connecting things, as I look at how much there is overlap in here, I'm strongly considering adding to your class the IoT security class. Now, if we go in here and look at this, let's pull up the scope and sequence together and look at this. So this is the scope and sequence for IoT. Now, they do recommend that you've had at least cybersecurity essentials and networking essentials. So this would be your students who've had Cisco 1 and a little bit of security. But you'll look here that it does ask you to have the prototyping kit, which is again described inside of there. But you'll also notice what you only need is a Raspberry Pi, a breadboard, 2 330K resistors, 2 LEDs, jumper wires, smartphone, and then on down through. So really there's not a great deal of equipment that's needed for this particular class, but you can see it looks at security in the IoT world, and it's not very long. It's only 6 chapters. So what do you think about this being an additional item? So in other words, originally I thought about a class that was fundamentals, connecting things, and that was it. But when you put those two together, it's about 45 hours. And then looking at it again, there's probably 5 hours of overlap. So it's probably about 40 hours of content. This is another 30-hour class. Well, 25 to 30, roughly, depending on how you look at it. Do you think it's worth putting this in additionally so that you could use this as another part for that IoT class? I'm open to opinions.
Sure, we can give it a try.
I mean, if you think it's too much, what do you think, Todd? You can put it in the chat. If you think there's now obviously y'all got to get through with the connecting first, but I do think you'll be able to blow through the connecting pretty quickly because there is a lot of overlap with what you've already done. Let's see
And when do you want us to be finished with all these?
The official end date for this class, and thank you for asking that. I was going to mention, I think the official end date is April 24th. Our next round of classes do not begin until May 21st. So I told my other class, my other instructor class, as long as you are finished by May 21st, then I'll be happy. Okay? Because, okay, that's good idea. Todd said it may be a bit much, especially when it hasn't taken the cybersecurity courses. Well, I'll look at it. I'll look at it, Todd, and see. I don't know. I think I'll make it available to you and see if nothing else, y'all can work through it if you want to, and then decide if it's for your students. But going back, the 21st is the drop dead date of May. I know y'all have all had a lot going on. If you're like me, I've actually been building a great deal of online classes for other people who have not been teaching online. And I'll go ahead and tell you right now, looking at this IoT stuff, trying to put industrial systems online is heinous. Some of that software is just evil. Anytime you have to use a dongle, a USB dongle to try to do software licensing, it's always a horrible. But because this class also doesn't have another class following it technically, I'm okay with waiting until the 21st of May for y'all to be finished. So official end date and the day that you will lose the ability to log in to moodle.stanley.edu is on the 24th of April. The official end date of this class, I'm going to end it on May 21st. So that should give you plenty of time, hopefully, to continue working.
So for fundamentals and for connecting, you want us to have those finished by April 24th?
If you can get them done by then, yes.
Okay.
And then
but then if you add this security one,
it'll be at least out to the 21st
of May. Okay.
So yeah, that would be at a minimum the 21st of that. If you get these other things done, then basically you've already completed what's required for the class. And so we can have some flexibility there. So. All right. Either one of you teach electronics classes? I definitely don't. I don't teach electronics, but here is an entire section on electronics, looking at some definitions of electronics. One of the things that I have learned through looking at these courses is that I need to beef up on my electronics, but looking at definitions of electric current, movement of electrons, I think this is going to be something too to be neat for your students, because some of your students probably had electronics in high school, and quite honestly, they may know more about electronics than you do. But that's not a bad thing. Use their knowledge in class. So
remember years ago in one of the old CCNA curriculums, there was an entire chapter devoted to electronics.
Yep, that was years and years ago.
Yeah.
Yeah, I remember that. Well, you're right. It was an entire chapter.
Uh-huh.
in that chapter, one of the things about these, when you talk about electrical conductors and what makes a good conductor, I always tell people humans are extremely good conductors because we're mainly water. That's one of the things I teach my students too, is you'll notice people who work around electronics a lot, if they're touching electrical equipment or if they touch any electrical equipment, they'll always keep one hand in their pocket. And the reason is because what happens if you put two hands on an electrical device, the current's going to run through those two hands and up through your heart, and that's how people get killed. So they'll keep a hand in their pocket so that other hand will not, they can't form a circuit with anything they're touching. Now, common sense says get a tester out to test it, see if it's got any electrical current in it. But the other thing you'll notice is most time, and always touch things with the back of your hand. That way, if it is there's a big electrical current and your muscles contract, they won't wrap around the whatever it is and end up killing you. Unfortunately, I actually worked at a pool in my after my freshman year in college, and we had a young girl get killed because of that very reason. She went to touch a device that was mixing the chemicals, and it grabbed her, and her hand went shut on it, and it killed her, which was terrible. But that's something you have to be very careful of. Looking at different things here, when we look at our circuits, so Ohm's law here, and that is looking at the fact that voltage is proportional to the strength of the current multiplied by the resistance. Okay, so voltage is current times resistance. And you can see Ohm's law in all its various forms here when you're looking at doing either voltage. You can figure, if you know voltage and resistance, you can get current, and you get resistance if you have voltage and current. So, basic law of electricity. Now here's a basic circuit, and again, it's funny. You'll notice that they're showing the flow of electrons from the positive side up through the resistor on down. Well, technically, in the real world, the current flows from the negative to the positive side, but we draw it like this simply because that's the traditional way of doing it. I thought that was kind of a really interesting thing when I learned about that. One of the things I will tell you too, when we start looking at building our own circuits and building parallel and series circuits, you see here's a series circuit. So it's a circuit that all of the devices are in line with each other, just like a serial connection would be. And then we have a parallel circuit where we've got a junction with two parallel paths going through. So one after another, or it splits into parallel pathways. So series circuit and a parallel circuit. Ooh, and again, it's funny how they're showing the plus going to the minus, even though that's incorrect. Now, folks, a lot of this in here, as far as looking at the different types of active linear and nonlinear circuits, I'll wait till you've read through it and get a little better idea on it. But just be aware, the big thing we're going to do with what we're doing in this class is we're going to be using resistors to reduce the speed of the flow of the current going to our LEDs, because the LEDs can only sustain a certain amount of current. And if you exceed that, you actually, you can pop them, you can blow them out. And trust me, another thing that will happen is if you put your LEDs in backwards, they won't turn on, or they'll barely turn on, which is something weird. Now, direct current AC, this is an interesting concept because in DC, the big thing about DC is it's usually produced by power, batteries, power supplies, solar cells, dynamos, and also one of the things you'll learn is that boats all use DC. They use DC current. So if you're on a ship, 99% of the time they're going to be running DC. AC is the flow of the electric current periodically reverses direction, and that is alternating current, which is what we use inside of our houses. You also learn, one of the things, I had 2 large D-slams donated to me years ago, and I was very excited about it until I got them in and realized they both run on DC power connectors, because they were designed to run off big batteries inside of a point of presence or inside of a CO area. And I was like, well, what am I going to do with this? I could have bought basically about the cost of buying new power supplies would have been more than what a new D-slam would have been. So it was kind of, I was like, well, I'm stuck with two big boat anchors. We eventually just scrapped them for the metal in them, quite honestly. These two types we'll be playing with mainly in our labs, some alternating current. This should be familiar to your students, analog versus digital. Analog uses varying amplitudes based upon and frequency. So you got an amplitude and you got frequency, which is the number of waves in a time span. Digital's ones and zeros. So it's the, well, again, we all know, depending on the type of encoding, it's either a 1 or a 0, and it's dependent upon the type of encoding as to whether that's the presence of voltage, a change in voltage, or any of those different ways to do encoding. Now this is getting into where you've got some large components. Looking at things like a solenoid, which can be used to, you can apply power to it and have it drive an actuator. So a solenoid can actually drive an actuator. A solenoid can be electrical, it can be pneumatic, it can be hydraulic. So any of those solenoids can be used. This is getting into like our PLC controllers. When we're taking a PLC and the PLC will control a solenoid, and then it can do things like turn a valve in a plant on and off based upon what is needed for a specific type of, let's say you're refining oil and you need X amount of this material. You could have a solenoid that would be driven by, electrical current would go to it, and then solenoid would move the armature based upon whether it's hydraulic, electric, or pneumatic. Hydraulics have always interested me, because if you think about what hydraulics can do, about how powerful hydraulics are. Now here's a little digital oscilloscope, which is kind of cool. You can kind of start seeing an oscilloscope. I've never played a lot with an oscilloscope, but they've actually put the little, circuit simulation tool in here. So it's kind of a neat little thing to let you see that. You can change the current speed, you reduce the current speed, and see what happens to the waveform. Oop. So, oop. So it's pretty neat stuff. Now, one of the things that's big in all of these IoT classes is the idea that you need to discuss with your students prototyping. The idea that when we build things, many times we do build a prototype, we try it out, we test it. If it doesn't work, then we go back and we revise it, try again. And that is a common theme throughout all the IoT classes, because one of the ending things in the class is what they call a hackathon, which is actually a class to where you give them a project and say, all right, let's build this. This is a picture of a solderless breadboard. In other words, it's a breadboard that you can put components into without having to solder them. We're not going to be teaching students how to solder, okay? But you'll notice that inside the breadboard, what is happening is, if we look up here, each one of these sides, now by the way, this middle line, one of the things I've learned here is the middle line separates the two sides of the breadboard. So when we look inside of here, if you plug anything into row 1, A, B, C, D, or E, you can connect another item into one of the ports here. So let's say I plug a power into A, I can put a resistor going to B down to 3. But you'll notice all of those A through E on row 1 are actually all connected together as far as on the back end layout of the board. Likewise, all of the items on the far left are positive and all the items on the far right, every one of those are connected. So if you provide power to any of those, you provided power all the way down the entire line. Now, that will be dependent upon your breadboard. in this particular instance, they're showing us this breadboard does provide power down the entire positive side if you put power on it, or negative, but or if you put a neutral in there. That's not always true on all breadboards, so you have to look for your breadboard to see what it's going to do. In this case, the way this one's set up, it definitely would be that way, because you can see here how it is designed. The cool thing is, like I said, you can notice here when you start putting things into the breadboard, you can anything that's put in the same row will be basically like you had soldered those items together, and that's why it's called a solderless breadboard. You don't have to solder it. You can just stick them in there, and they will appear to be connected, because they are connected on the back end of the breadboard. Be aware that one of the things I've had problems with in the past, especially with my hands, because I don't have good feeling, and with resistors especially, when you're trying to push them down into the breadboard, when you're doing projects, make sure you've actually got them pushed all the way down into the breadboard. The other item you got to be real careful of is, and like in this instance right here, when you've got a bunch of wires close to each other, make sure none of those wires are touching each other to short things out on your breadboard itself. So you have to pay attention. It's not going to cause any major problem. We're dealing with such small amounts of electricity. It shouldn't cause, you may hear a pop, you may kill a resistor or something, but it's not going to be anything major. So, but it could definitely make it to where your project wouldn't work. So be aware of that. How familiar are the two of you with breadboards? Have you played with them at all?
I have not.
They are. It's a lot of fun. Okay, Todd's familiar with it. Todd, have you taught? Oh, there she goes. Sorry, I was watching a lot launch on the other. All right. Todd, do you teach electronics, or have you taught electronics? Okay. All right. Well, all this is, I probably should let you be teaching this part, because like I said, this is not my forte. I do like playing with the breadboards though. It's a fun thing to do. I will tell you this, I learned this the hard way. On your LEDs, the long leg's the positive leg. And it's also the leg that looks like, when you look at it in the diagrams, it looks like they show like a cut in it, or it's got a little, instead of the straight line, it's got a little crook going out and then down. That's typically the positive side. The other thing about the many of your LEDs, there's a flat side on the leg that is the positive side. Now that wasn't true of my Free Nove ones, but that is true on some that you will buy. So it is something you can look out for. Now, once we prototype something, once we actually design it, oh, how in the world did I miss that page? So once we design it, we prototype it. Then once the prototype is working, then you actually go into a production phase where you take and create printed circuit boards, or PCBs, where they're able to go in, and on the back end, everything's soldered to by a machine. And so you got a layer, and all the components that you need for your electronics are placed onto those boards. Pretty much they're used in everything. I mean, everything. So one of the neat things that one of our electronics guys do is they actually have a project that typically lasts the entire semester, and they have to go in and solder their own FM radio. They build their own FM radio. Okay, I got a new electronics degree beginning. Okay, that's neat. But they have to create their own radio, which is a really long project. And basically their score is, if the radio works, they get 100. If not, then he has to start going in and checking and seeing where they made a problem. But as long as the radio works, they get 100 on it, which is pretty neat. All right. Now, again, this is a Spark Fun kit that you can get. Internet, I'm gonna let this clear up. All right, my internet was unstable there a little bit, but you'll notice it's basically a breadboard. There's an Arduino clone, just like in my kit, the Free Nove kit. And then there's some components here, USB mini cable, resistors. I do have, and I've just got to the last week or so, a document camera. So I'm actually going to be doing some, try the next class, I'll have my document camera set up, and I'll show you putting some of the stuff into a breadboard and playing with a breadboard. So that'll be good. I showed this last week, or well, wow, it was 2 weeks ago, wasn't it, Kendra? That was crazy.
Yeah.
That's nuts. Freenove.com. This is a company that I have found that sells a kit, and that kit, and I think eBay is the only place now that you can get the kit at this moment. It's not available anywhere else. But it's Ultimate Starter Kit with a control board, and this is an Arduino kit, and it's $35, $36. Right now, in fact, Carlos Bowden, who was in our class, but he was at our meeting last week, ordered a couple of them, and it said that he wouldn't get them until April, but he's already got them in. So it may be that you can get them quicker than right what it's saying here. This kit is amazing for 36 bucks. It is an Arduino clone. It is all of the connector cables you see here. It's the breadboard, solderless breadboard. They do actually give you some solder breadboards that you can create your own solder projects with or solder projects with. There's a little remote. There's an LCD screen. It's all kind of LEDs, all kind of little buttons, potentiometers, all kind of stuff. A little motor. For 35 bucks, this thing just tickles me to death. I've got 2 of them myself that I have. Now the negative is obviously many schools won't let you buy off of eBay. But if you have students, this is something you might just have them go buy themselves. Now, every bit of this, and in this kit here, every bit of this kit's about $100 for the SparkFun kit. Now, this kit is 36 bucks, and it's got way more than this kit. Now, having said that, the labs are written for this kit, but every single lab that you can do with this kit, you can do with the Freenove kit. And one of the cool things, and I know, Kendra, you've seen this before, but maybe some of the other classmates who will be watching this won't. One of the cool things is there is actually a over 200 page, I got to download it. Lord, I got slow internet. Over 200 page kit that shows you all the different projects that you can do with this kit. So let me go show this in the folder here. And so give you an idea, when we look at this tutorial, if you want to look at some of the things that are possible to do, let's do fit one page, read one page. In the Freenove kit, the first project is blink an LED with a manual button. Okay, so you click here, you'll notice that very first project is this kit with a breadboard, a resistor, an LED. By the way, that is the positive side, just so you know, and that is also the long side. Won't tell you why it took me, why I messed that up. Push button here, but you'll see this kit. And if I go back to connecting things and I actually take us to one of the very first labs for the kit, it is blinking an LED using an Arduino. So we're basically doing the exact same thing with this breadboard that's available in the kit that sells for 35 bucks. Okay. Again, Cisco probably hates me for that, but guess what? I don't care. It's cheap and it's good for y'all. So here's the other thing. If I look over here, looking at lab index, RGB LED using the breadboard. All right, so you're looking here, creating different LED that changes colors. I'm not certain that one's in here, but I think actually, let's see. Yep, here it is, RGB LED. And you can actually do it through a potentiometer. So you can take this multicolor RGB LED and you can use the potentiometer. I think I'm saying that correctly. If not, I'm a redneck, forgive me. But you put that in there and then you can change the color based upon how much you change these through potentiometers. And so you can see it's got your circuit built out. It shows you how to do it. You also can, you know, it's a little bit hard to see, but you can zoom in. So this kit is a phenomenal kit. I can't say enough good things about it. If you've never seen the Freenove stuff, and again, thank Ken Kwame from up in North Dakota. He put me onto it at NSF grant conference. He said, hey, this is what we use for our IoT stuff because of how cheap it is and because of the fact that oil and gas industries use Arduinos, not really Raspberry Pis. I see. Here's Kit's been experimenting. It's not too much more expensive. Let me see it. So it's on Amazon. Okay, so it's from the same group though. No, it's Eligo, a little bit different. Okay, very similar. How much is it? Oh, that ain't bad either. No, that ain't bad at all. And let me tell you, the thing is, and I think it will be back here, Todd, but they did have it. It used to be, in fact, I bought my first two off of here. So they used to have it here, but for whatever reason, they no longer have it on this store. So I don't know if they're gonna have it again in the future. There's an Ultimate kit for Raspberry, but the Ultimate Arduino kit is no longer on their Amazon store. But that is not a bad little price either. Not bad at all. And that's exactly the way mine looks. It comes in that little kit. Random shipment of a new package, okay. So they're all pretty much close enough. Yeah, that's not a bad kit at all. As long as you've got the components, if you go back here and look at the connecting things, as long as you've got the components that would be inside of the kit itself, as long as you have all of these different components, it really doesn't matter how you get them, okay? But these are the components that are minimum that will be needed to do the labs. You can always adjust them. You know, if you just want a blinky light, again, they've got a thing here. If you don't have an Arduino controller, there's no reason if you didn't have one, you can do a simple circuit with just using a battery. You know, just put a little LED in there and a battery and a resistor, and boom, make you a circuit. Have any of you ever done a circuit with what was it, an orange? You can do it with an orange or potato. I think you can make it actually show how that works. I haven't, but I've seen it done. So here's the Arduino Ide. This exact same thing we use for my for the FreeNovae kit. Yeah, we did it in high school. Yeah, we did that too. It's pretty cool. But this is the code, and it runs a version of C or a type of C, but they call them sketches. But it looks like a little version of C that you're running there. I will show you some examples next week with my document camera that I've got from school. So I'll actually run it and show it to you. But again, as you can tell, Kendra, and you missed the actual class during NCCIA, but we actually went through and did some labs and did a couple of the labs with Arduino. So it's
Tim told me.
Yeah, it's actually pretty cool. They're really neat. But I'll show you everything we got to do next week, and I'll show you the first couple exercises inside of the FreeNovae kit. I do own a Cana kit. I don't own one of these Arduino red kits right now. I've got the Raspberry Pi kit, and have shown. In fact, I gave y'all or sent y'all a link to the lab when I showed you my blinky light with the Raspberry Pi. I'm easily impressed, by the way. Just you know.
Now, Kelly, these in the fundamentals course, those 4 optional labs where you have to have the actual equipment.
Y'all don't have to do those. You don't have to do them if you don't have the equipment. That's, you know, if you don't feel like doing those or don't have time to do them, that's fine too. And same thing with this connecting things. If you don't have time to go get the lab or the equipment, especially now considering the fact that how bad people are in terms, I mean, just trying to get anything ordered right now at your school is almost impossible. You know, if you wanted to, I would say go ahead and, you know, maybe drop the coin and try to get one of these, you know, from eBay and see if you can get it in here in time to start playing with it at least. I don't feel bad about asking you to spend $36 of your own dollars. Of course I do now because, I mean, the way things are right now. But you know, that's 36 there you could drop, or I'll probably order one of these kits, just take a look at it and see what all's in it. A quick question for you, Todd. Does this come with a, like a tutorial? like does it have like a tutorial thing that controller board, 200 components. Let's see, ELO Go. I guarantee you could use the exact same tutorial that I was showing you and do every one of these for the most part. Let's see, that LED potentiometer. Let's go back and look at. I got to slide over my thing here. Might not can do that. Oh, yeah, there's one. I think this kit has everything you could do. It has a bunch of labs with the kit, so like this must just be another company very similar. Oh yeah, there it is. ELEGO.com. Let me go there. ELEGO. I bet this is probably just another name for the same company that makes FreeNovae. Let's see. There's Arduino Ide. I'll do some look. Yeah, I think they do. Yep. Okay, what was the name of this one again? Uno R3 Most Complete Starter Kit. Okay, there it is. We may have found us another supplier, folks. I love stuff like this. I mean, when I find good deals like this, I'll let this download and we'll take a look at it. But it looks like it's the exact same type of thing, just a different company. So there's another option, folks, that we have. Thank you, Todd, very much. But ELEGO.com, and you can buy it from Amazon, and it is $55, I believe, $55. So a little bit more expensive, but it's also got, I think, a couple more components. Because it looks like it might, or it looks very similar. It looks like it's got about the same components as the other one, just a little bit more expensive, maybe a little bit more. It's got a lot, though. What is that little thing? The blue thing. Anybody got any idea what that is? That right there? Looks like some kind of key fob.
Mm-hmm.
Be interested in seeing what that is. You still got a cough, Kendra. Stay away from me.
I know. And
I had that when I had the flu. When I had the flu back in February, golly, I was sick. I did actually test positive for the flu though. RFID module. Oh, cool. Yeah, now that does that. That's why it's $55. That's definitely more than what's. There's not an RFID module in the in that other kit. You have to buy a special RFID kit. That is neat. Yeah, that's cool. Let's open this up. I will tell people that sometimes the language is a little bit English. You have to translate it, but it's not usually that bad. Actually, this is really nice. In fact, I bet you money that the exact Arduino board is the same board because there's not a whole lot that's different. Wow, this might be worth getting just to have if you're not using the kit, to explain Arduino, any Arduino board. Neat. Okay. Thank you, Todd, for showing us this, because this is really cool. This is showing you how to load the Arduino environment, which the other one does too, but I'll be interested. I'm gonna pull my board up and look at it and see if it's not exactly the same thing. Neat. All right. I gotta see one more. Blink in the add library. So you're doing a program. My Blink. Okay. They've got a different set for their sketches. They call it somewhat different. Still sketches though. Still using the Arduino integrated development idle. That is cool. Yep. Everybody does blinky lights. In fact, that is the exact same sketch. I mean, that's on in the other kit. I guess it has to be because there's only so many ways to write a sketch. But. Okay, cool. I'll take a peek at that. I should have closed all tabs. All right, so that's something that's available, folks, that we can use as we move forward. All right, I am going to stop here. I do want y'all to know that you've got, again, to the 31st or 21st to get everything done. If you don't get it done by then, that's fine. I'm going to add the security in probably next week, but it won't be until after next week or late next week before I will do that. I'm going to stop.